Okay, so we're going to have a little look at geometric series today. Okay, so you'll remember from a geometric sequence, your A is your first term, so that's T1, and your OR is your common ratio. So what are you multiplying it by? And to get your OR, you just divide the second term by the first term. And this was your Tn for a geometric sequence. So A or to the power of n minus 1. Okay, so for a geometric series, we have Sn. Okay, which is a1 minus r to the power of n over 1 minus r. Okay, now that is in your log tables here on page 22. Okay, so you don't need to learn that off. So for example, find T5 and S5 of. So the first series is 1 plus 3 plus 9 plus. Okay, so that's my first series. So I know my A is 1 and my OR is the second divided by the first, or the third divided by the second. Okay, so my OR is 3 here. Now to get T5 I'd need to find Tn first. Okay, so Tn is A by r to the power of n minus 1, okay, which is just 3 to the power of n minus 1, and T5 then happens when I fill in 5. So that's 3 to the power of 4, which is 81. Okay, that's T5. Now to find S5, I'm just going to use this formula here. So Sn is A 1 minus 3 to the power of n over 1 minus 3. So just filling in my OR there. Okay, so Sn is 1 minus 3 to the power of n over minus 2. Okay, and then you shouldn't have a minus on the bottom, so just pull that up. The minus comes in front of all of the top line, so it'll change it to a minus 1 and a plus 3n over 2. So that's my Sn there. Okay, now that isn't necessary, but if they did just ask for Sn, you should do this. Because they've asked me for S5, I could have even filled in, instead of n, I could have filled in 5 back here. Okay, but filling it in here, 3 to the power of 5 over 2. Okay, and what I get when I throw that into my calculator is 121. So that's part 1 of that. Now let's look at part 2 when our OR is a fraction. Okay, so same thing, T5 and S5, but this time my series is 1 plus 1 over 4 plus 1 over 16. Okay, so our A again is 1 and our OR is 2 divided by 1, so a quarter divided by 1, which is a quarter, or 1/16 divided by a quarter. You can throw that into your calculator, you'll still get a quarter. Okay, so Tn is A or to the power of n minus 1, which is going to be a quarter to the power of n minus 1. Now, when I have a fraction to a power, I put the power on the top and the power on the bottom. Now, 1 to the power of anything is always 1. So really, this is what my Tn is. Okay, the n minus 1 goes on the top, the n minus 1 goes on the bottom, but 1 to the power of anything is still just 1. Okay, that will always be the case. So for T5 then, I'm just filling in 5 instead of n. Okay, so that's 1 over 4 to the power of 4, which is 1 over 256. Okay, and then for S of 5, let's get S of n first. So A 1 minus a quarter to the power of n over 1 minus a quarter. Okay, so it's the OR to the power of n. OR is the whole quarter to the power of n. Okay, so just to tidy that up, that 1 is unnecessary, so it's 1 minus 1 to the power of n over 4 to the power of n. 1 to the power of anything is just 1. So again, you get 1 to the power of n over 4 to the power of n, but you don't need to worry about the 1 to the power of n because it's just 1. And then 1 minus a quarter is 3 quarters. Now I have this and I'm dividing by 3/4, and we know that's the same as turn it upside down and multiply. Multiply by 4/3. Okay, so 4/3 by 1 minus 1/4 to the power of n. Okay, or the 4 on top and the 3 on the bottom, totally up to you how you want to do that. Okay, and now if I'm interested in s of 5, I'm just going to fill in 5 down here. And throwing that into my calculator, I get that. Okay. Now, let's just do another example where they're giving me different information. Okay, so in a geometric series, T3 is 32 and T6 is 4. Find A and R, and hence find S of 8. So that's the sum of the first 8 terms in your series. Okay, so you know you're probably going to have to do some form of simultaneous equations. Okay, so let's go back here again. Here's my formula. Okay, Tn is A by R to the power of n minus 1. So if T3 is 32, T3, which is A R to the 3 minus 1, which is A R squared, that's equal to 32. Okay, and T6 is equal to 4. So A R 6 minus 1, which is A R to the power of 5, is equal to 4. So I have two things here. A R squared is 32 and A R to the power of 5 is 4. Okay, now, easiest thing I think is to get one variable on its own. So I'm going to get A on its own here. So that's going to be 32 divided by R squared. Now over here, anywhere I see A, I'm now replacing with this. Okay, so 32 over R squared by R to the power of 5 is 4. Now, the R squared goes in there and I'm left with a 3. Okay, so remember with indices 5 over 2, what you do with your powers is you minus them. So 5 take 2 gives you the 3. So this is 32 R cubed equals 4. So R cubed is 4 over 32. R cubed is 1 over 8, so R is the cubed root of 1 over 8. That can go straight into the calculator, or you can get the cubed root at the top, cubed root at the bottom. Cubed root of 1 is just 1, cubed root of 8 is 2. So R is a half. Okay, now that you've found R is a half, you can just fill it back into any of these. I'm going to go back here. A is 32 over R squared, so A is 32 over a half squared, and you can throw that into your calculator. A half squared is a quarter. 32 divided by 1 over 4 is the same as multiply by 4 over 1. So 32 by 4 is 128. Okay, so there's your A and there's your R, and hence find S of 8. So I'm just going to get out my formula for Sn. Okay, I know that A is, I just found it, 128, or is a half. Okay, so let's S of 8, just going to fill everything in. So 128, 1 minus a half to the power of 8, okay, over 1 minus a half. And you can just throw that straight into the calculator and you get 255. Okay. Now, when you're or looks like different things. Okay, so these are a few scenarios. Okay, your common ratio, so you're multiplying by something. If what you're multiplying by is bigger than 1, okay, now we're not interested in whether it's positive or negative, just if it's bigger than 1, the modulus, the absolute value of it, okay, what you end up with is an exponential, okay, it increases rapidly. Now, if your OR is 1, your series ends up looking like linear, okay? And if your OR is less than 1, what happens is you approach a limit, okay? So you have a limiting value. Now, again, it's given to you in your log tables. You can find the limit of a geometric series as n goes to infinity by using this, okay? But you can only use this if your common ratio is less than 1, okay? So you have s to infinity, the sum to infinity, and this comes up a lot, okay? So we'll just do a little example. So sum to infinity, okay, the limit as n goes to infinity of Sn, okay, and that formula is a over 1 minus r. But that's only if your common ratio is less than 1. Okay, you can use this formula if your common ratio is less than 1. So, for example, find the sum to infinity of the geometric series 16 plus 12 plus 9. Basically, you can see this is decreasing, okay? So our common ratio is a fraction that's going to be less than 1, okay? Now, because of that, we know it's going to approach a limit. So finding the sum to infinity is finding the limit of that Sn, okay? So all you're going to do is you're going to find your a, you're going to find your r, and you're going to throw it in here. So a is my first term, which is 16. R is the second term divided by the first term, okay? 4 goes into each of those, so R is 3 over 4. Now, to find the sum to infinity, what you're going to do is this, okay? So the limit as n goes to infinity of Sn is, so we know that is a 16 over 1 minus 3 over 4. And you can just throw that into your calculator and you get 64. Okay, so the sum to infinity of the geometric series. So it doesn't matter how many terms, if you continue adding a huge amount of terms together, you're going to get 64. That's going to, your number is going to approach 64. Okay, so the sum of an infinite amount of terms in that series will approach 64. And the last thing we're going to do is recurring decimals. So they're just little subheadings here in this topic. So recurring decimals, you know, you've seen them on your calculator when you've got a dot. So for example, 0.3 with a dot above it means 0.333 and so on, okay? 0.235 with a dot over the 3 and the 5 means 0.235, and then it repeats 3535. So this is the start and this is the end of the repeating pattern, okay? You can throw it into your calculator and press S to D if you want to see. So an example here. So write the recurring decimal 0.23 as a fraction in the form a over b where A and B are an element of n. Okay, so write the recurring decimal 0.23 as a fraction. So to write it as a fraction, what we have to do is we have to write it as a series first. Okay, so 0.23 with a dot over both means 0.232323, and so on. Okay, so really what that means is it's 0.23 plus, now these two are gone, so 0.0023 plus all of these are gone, 0.000023, and so on. Okay, so that's actually a series now. That's how you get this number. Now in this series, you can see this is 23 over 100. This is 23 over 10,000. If you're not sure, you're just going to go straight to your calculator. 0.0023, 23 over 10,000, okay? Or you've got 4 places after the decimal, that means 4 zeros underneath, okay? In this one here, we've got 1, 2, 3, 4, 5, 6 places after the decimal, so that's 1,000,000, 6 zeros, okay? And so on. So from that we can see A is 23 over 100, our first term, and OR is whatever you're doing, whatever you're multiplying by to get from the first term to the second term, okay? Now, I can see that I had to multiply by 100, but if you're not sure, all you're going to do is the second term divided by the first term, and you can just throw that into your calculator. So the second term divided by 23 over 100, and you get 1 over 100. Okay, so that's what my OR is. Now, to write it as a fraction, you're going to get the limit, okay, as n goes to infinity. So we're going to use our sum to infinity to write this as a fraction, because we're adding on an infinite number of these and we're trying to see what will it approach, and it will approach a number. Okay, so there's my A and there's my OR. So I'm going to get the limit as n goes to infinity of Sn, and I know that is A over 1 minus OR. Because my OR is less than 1, I can use this formula. Okay, so that's going to be 23 over 100 over 1 minus 1 over 100. Okay, and you're going to throw that into your calculator and you're going to get 23 over 99. So now you've written 0.23 with a dot as a fraction, and you've done it by using your sum to infinity of a geometric series. Okay, so that's your answer there.